Hello, welcome to lesson 1 of Liberty Basic. This is Computer Science 20S. Okay, so we're going to move into the text-based Liberty Basic part of the course. This will be an entirely new environment for you to be programming in. This program is available on the computers at school as well as on the network drive. I can show you where to find that. And I also have a license for you to use this at home. If you would like to go to the website listed below, libertybasic.com. You can download it for free. You can register it using my name and this number here, 958-914. I'll show you how to do that right away. So if you wanted to do that, if you were at home, you could do that now. Pause the video, and I'm just going to show you now what Liberty Basic looks like. So when you're in Liberty Basic, you're basically going to see a big blank screen. Now, when you first default this, other programs you might see some sort of code, but basically it's a blank word processing document. Okay, now to register the program, you go to enter registration code. This is for upgrading, so you would enter my name in here and the 958-914 number down here under password. Okay, so now that you've done that, let's have a look at, see what Liberty Basic can do for us. So Liberty Basic is a different type of software environment. In this particular one, you have to type in the commands. There's no set list of commands that you can select. You have to actually do the typing, which means your typing could make mistakes, which could cause problems. We refer to this as a procedural language, which means it operates from top to bottom. I should read top to bottom. Things happening simultaneously are a little bit harder to code, so Liberty Basic has some difficulties with that type of thing. The programmer has to do more of the heavy lifting, less is done for you behind the scenes. So you have to actually sort of take care of a lot more details. Scratch is very user-friendly. The downside to that is that you're sort of restricted to doing the things that Scratch can do. Whereas here, because you're more responsible for some of the details, you can do more powerful things. So that's what I've got here. More powerful than Scratch, you can do more. It struggles a little bit with the visual, the graphical. We'll get to that in the second half of this course. And as we progress in grade 11 computer science as well, you'll see the more visual, the Windows-based type of stuff. Okay, so when you open up Liberty Basic, you should see a window sort of like this. You can just close that World of Basic box. It's just sort of a welcome screen. And what I would like you to do is I would like you to type in this program. This is your program right here. It has 1, 2, 3, 4, 5 lines. So I'd like you to take 5 minutes, pause the video, and type this into Liberty Basic. Okay, so you should have typed that in. I'm going to do the same here. All right, so we just start with going input. Okay, so here's my program. I've got a little spelling error here, but this should run even though I have a spelling mistake in there. We'll just sort of show you what happens here. So I'd like you to type this in Liberty Basic, and then I'd like you to run the program. Now you'll notice here that there's no green flag or anything like that. To make the program run, this is the button that you click right here. This is the run button. It looks like a play button, like on a CD player or on an MP3 player. So we'll click that. And it opens up a new window, and now the program is running, and it's asking me what is Mumber1. Okay, of course I've got a spelling mistake here. So if I type in my two numbers that I'm going to add together, we'll say 5 and 3, and it gives me the answer is 8. Okay, so to close this, we're just going to X that out. I'm going to fix this little spelling mistake right here. Okay, certain spelling mistakes are allowed, others are not, and we're going to find out what those are sort of shortly. Okay, so let's have a look at this program. Liberty Basic uses variables as well. We've got 3 variables here in this program. So variables are the same idea as Scratch. They can contain numbers, or values, or they can contain letters or strings is what we refer to them as. In Liberty Basic, in Scratch, there was no distinction made between the two. So in this program here, we had 3 variables. What are they? Well, they are number 1, number 2, and they are answer. So what we did here is we got number 1, we did an input, we get number 1 from the user, we get number 2 from the user, and then we take number 1 and number 2 and we add them together and we call that answer, and then we print it. So for now, the variables will generally be integer or whole number values. They could be decimal values too. Liberty Basic does not treat them different, although other programming languages make you declare whether they are an integer or a decimal value ahead of time. When you're naming your variables, just like in Scratch, you should use a variable name that means something. Call it length, call it width, call it perimeter as an example. Back in the good old days, you were only allowed, I believe, 1 or 2 characters for your variables, so we had to call them things like L and W and P. And then you had to have a dictionary that sort of said, well, L referred to the length and W referred to the width and so on, okay? There was a lot more documentation needed. What does this mean to document? Okay, well, documentation refers to the adding of comments to a code to help understand the program. And we did this in Scratch as well. We did documentation. We did our comments. Who is it for? It's for debuggers and people looking at the code, people that are trying to fix it. Maybe you're working for a company and you've written some code and then you decide to leave that job and then someone else is in charge of that program. They need to be able to look at your code and determine what exactly it is that it's doing. So it also assists with your programming. It allows you to find bits of code, chunks of code. It's a very, very good habit, and I will be grading it as well, so you need to do documentation, just like comments. Okay, so here's an example of a program that has the documentation done. So I've got add 2 numbers version 2. I've got a apostrophe here, add 2 numbers together, there's my name. After the number 1 here, I've got another apostrophe with get first number. Now we really don't need to document that. Most people will see an input and know what it's doing. Generally, you would document a chunk of code, and I showed you how to do that a little bit in Scratch. So the apostrophe signals that anything that follows is just comments and is ignored by the compiler. And there's 2 things I need to talk to you about that. Okay, so first of all, let's just go into our code here, and let's put an apostrophe, and I'm going to say display answer. Okay, so basically anything after that apostrophe is ignored by the computer. It doesn't do anything, still runs exactly the same way. Okay, the compiler, I need to talk to you about what the compiler is. Okay, so the compiler is primarily used for programs that translate source code from a high-level programming language to a lower-level language. Okay, so what the heck does this mean? A high-level programming language, much like Liberty Basic or something like that, down to an actual language that the computer can actually understand. Okay, so the computer doesn't actually understand this. This is all converted into what we call machine language, which is very complicated to read, but that's how the computer operates it. So it's basically like a translator. It translates your program into a language that the computer system understands. And Scratch actually did this too. Scratch was based on the Smalltalk 80 language, and it actually compiled Scratch code into machine code to run. So if you want to think about it this way, it's kind of like the nesting loops kind of thing. Scratch was a program that was written in another type of software, much like Liberty Basic, and then the Liberty Basic program converted your Scratch program into machine code so that it could actually run. So you're actually sort of 2 levels away from machine code there. In Scratch. In Liberty Basic, you are like 1 level away from machine code. So that's what it means to compile. It means to translate into a computer machine language, computer language that it can understand. Okay, so documentation. It also links the pseudocode to the real code. Can be used to just fill in the blanks. And this is more about game design here. You can leave out the code and just add a comment telling you what goes in that spot later. Okay. So let me just talk a little bit about pseudocode here. When you're sort of doing a program, it might be a good idea to think about your plan. This is what a pseudocode is, okay? So we're going to get number 1, we're going to get number 2, add them, and then display. That's sort of the steps that I need to do, okay? And so what you can do is you can do this ahead of time with apostrophes, with comments, and then as you are coding, then you would type Okay, get number one, what do I have to do that? Well, I have to input what is number one. Okay, and then as you're doing this, your pseudocode becomes your documentation. Okay, so start with sort of English, start with your plan, and then convert that plan, translate it into computer code. Okay, it's a very, very valuable sort of process to go through. All right. The print syntax, I need to talk to you about syntax a little bit. Syntax refers to the grammar of the command. In Scratch, you do not need to worry about it because all you were doing was you were clicking and pasting from the tablets on the left-hand side. Here, because you're typing, you need to worry about the grammar, the syntax. So when you're printing something, you can print a variable, like I did here, print answer. If I just went like this, if I just print the answer, I'm going to get my answer 8, okay? The variable here is the answer. If I print the word variable in quotations, if I print answer in quotations, then I don't get my number 8. I'm going to get the word answer, okay? So there's a difference there. So that's the syntax. You can also do this type of thing. Go answer is, put a semicolon here, okay? And then so it will print the quotations, and then it will print the actual value of the answer, like that. Okay. Input syntax, very similar idea. Input is very similar to print, except it stops and it waits for an answer. So input variable will pause the computer waiting for you to enter value. It's very similar to the ask command in Scratch. If you use something like this, input, what is the value? It will display, it will print the stuff that's inside the quotations. In this case, it's the what is the value sentence, and then a semicolon variable, and then whatever you type in as the variable, when the user types in the answer, then that is assigned to that, much like we did over here. Okay, what is the number? It's a 5, enter. Okay, and so now number 1 becomes equal to 5. Number 2 becomes equal to 3, and then the answer is the 5 and the 3 together gives us the 8. The semicolon is important. If you don't have it in the input, you will get a syntax error. Okay, and it says here, basic compile halted syntax error. You have to look at this and try and figure out what's going on here. Oh yeah, I'm missing a semicolon. Okay, so that's a syntax error. Okay, so I would like you to take a minute and type in this piece of code here, the area and perimeter of room, and then let's have a look at it and see what it does. All right, you should have paused the video while you were typing that. Here I've got mine typed in. I've got my inputs. You'll notice that I put a few spaces in my code here. It just makes it a little bit easier to read. It's just a visual thing. Some people like to have your comments sort of all lined up. Okay, they can be spaced out as well. They don't need to all be sort of jammed up against the code itself. Just makes it more visual, makes it easier to see. Okay, so in this case here, I've got input. What is the length of the room? We're going to call that the length. Input, what is the width of the room? We're going to call that width. The perimeter is 2 times the length plus 2 times the width, so that calculates the perimeter. And then it determines the area by taking the length multiplied by the width. You'll notice that the star is used for multiplication. Then I've got a couple of blank line. I've got a print. Then a print the perimeter is. So I've got over here, what do these 2 blank print lines do? Well, what they do is they do a blank print. So if I'm going to say my length of the room is 10 and the width is 5, you'll notice that it prints some nice blank lines here. It formats my output a little bit, makes it a little bit nicer to read. So that's something that you should consider doing when you're writing a program. Perimeter is 30, got 10, 2 sides of 10, that's 20, 2 sides of 5, that's another 10. Perimeter is 30, the area is 50, 10 times 5. And so that's just a little sort of area and perimeter program that you can type in and try. I would like you to now try this one. This is a practice question. So a shop owner requires a program to calculate the amount of change to be given to a customer, the price of the item sold, and the amount of cash given by the customers to be input, and the amount of changes to be calculated and displayed. So here's a couple sample runs. Here's what it should look like. If you type in a price of $8.95 and the cash given is $10, the change is $1.05. If the price was $20 and the person gave him $20, then the change should be 0. So go ahead, take 5 minutes, pause the video, and give that a try. Okay, by now I'm hoping that you've got that done fairly well. I'll just give you the answer here. So you're going to input the word price, $, and the quotations. We'll call that price. We're going to input how much cash is given, and we're going to call that cash. The change is then calculated. The change is equal to the cash minus the price, and then we print change equals and the actual value of the change. Make sure, now actually I'm going to leave this mistake right here. You'll notice that I've got a capital R. This is a lucky mistake that I've made here. You'll notice that when I run it, let's use the sample numbers that I've got right here, $8.95 and $10, it gives me a change of 10. And the reason for that is you'll notice it down here in the box it says similar variables price and price. Because I've got a capital R here and a small r here, it thinks that they are different. It's telling me that they're very similar. Do you want them to be different or do you want them to be the same? And that's why it didn't work. So I got to change that to a small r and then it should work. Okay, and there's my $5. Oh, I forgot my $sign here. I'm going to need something like that in there to make it work. Okay, so that's the change program. Here's a tax program. Write a short code that inputs a price and then determines the total price including the tax. To determine this, multiply the price by 1.12. That's, of course, our tax rate here in Canada, in Manitoba, 5% GST and 7% PST. And this is what it should look like. It should ask, what is the price? $4.99, and then that's using an input. And then it should print the total price with tax is 5.58888. So try that, pause the video, and then I'll show you the answer. Okay, I'm going to use this program here as sort of a base for this one. Rather than inputting the price, I'm going to say, what is the price? Question mark. We're going to call that price. I don't need a second input. I've got change equals cash minus price. I don't want that. I want something like total equals 1.12 times the price. And then I want to say print total price with tax is. I don't want to do that. I want to use the word total. Okay, let's see if this works. What is the price? $4.99. Total price with tax 5.5888. Okay, so that worked. Hopefully you got that as well. I would encourage you some file management, just some sort of housekeeping items here. On your H drive, on your directory, or maybe on a flash drive, you need to set up a folder titled Computer Science. In that folder, you should set up a folder called Liberty Basic, and then Unit 1. We're going to have 2 units. In that folder, you should set up 2 folders, one for practice assignments and one for hand-in assignments, just to keep them separate so that you know which ones should be handed in. Try and keep your programs organized, and then when there's a problem with handing something in, it'll be much easier to find. Print using is a nice little feature. When you're printing dollar values, you may want to round to show 2 decimal places and a $sign. So instead of just the print total price with taxes, you could have done something like print using quotations, $sign, and then there's a whole bunch of number signs here. Basically what that does is it leaves 1, 2, 3, 4, 5 places for the dollars, 2 places for the cents. It's going to round it off, and it's going to print the word total. It's going to print the variable total using this sort of template, this format, and it's going to use a $sign there. So if you want to try and type that in, you can. Print using isn't used too much anymore, but it's a handy little thing. Okay, so here's hand-in number 1. I would like you to write a documented code with appropriate variable names. Be sure to include your name, date, and name of program as comments at the top of the program. To hand in, you have to need to log into Edline, click on Assignments, and you should see Unit 1, Liberty Basic, Hand-in 1, and your file name should be Unit 1, Hand-in 1. And it should include your name on it, because that way I can keep track of who's handing stuff in. Okay, so it's just a little 4-mark program just to make sure that you can do these. A store owner requires a payroll program. The program will allow the store owner to enter the worker's wage and the number of hours worked. And so the sample run, this is what it should look like. It should ask for the wage, $9.50 in this case. It should ask for how many hours worked. In this case, the user would type in 35. And the payroll amount, which is calculated, so these are both going to be inputs. Payroll amount is going to be wage times hours worked, and it's $332.50. Okay, and see if you can use the print using to make that formatted correctly. Here's a little rubric that goes with that. Please take a few minutes now and do lesson 1 hand-in assignment.